Start. Okay, dear students, I'm going to solve physics paper now. So here is the question number 1 on your screen. And in this question, if the galvanometer does not show any deflection, where is the mic? Fine. In this question, if the galvanometer capital G does not show any deflection in the circuit, you have to find the value of R. So in this question, pen is not working. Previous page. This is a 10 volt. And deflection through the galvanometer is 0. It is 0, this means current is not passing through the galvanometer. So across resistor, there is the potential difference of 2 volt. Then only it is possible. The current through the galvanometer should be 0 if it is 2 volt. Now this is 8 volt because 10 minus 2 is 8. So we can easily find the current through it. The same amount of current is passing through this. So current is how much? V by R, that is 8 by 400. So from this, current is 2 by 100. And same amount of current is flowing through the resistance R. So we can write I into capital R, it is equal to 2 volt. From this, resistance will come out to be 100 ohm. Second option is correct. Let us move to question number 2. A full wave rectifier circuit consists of two PN junction diodes, a center, trapper, transformer, capacitor, load resistance. Which of the following components remove AC ripple? Capacitor act as a filter. So here the capacitor is the answer. Option 2. Let us come to question number 3. Carnot engine, it has efficiency of 50%. When its source temperature is 327 degrees Celsius, the temperature of the sink. See here, this is 327 degrees Celsius. We can convert it into Kelvin. So just add 273 in this. So it will be equal to 600 Kelvin. Efficiency, we have a formula, it is 1 minus TL by TH. TL is the temperature of the sink. Efficiency is 50%. So 50 by 100 equal to 1 minus TL by 600. From this we get TL is equal to 300 Kelvin. Wait a second. We can convert it into degrees Celsius by subtracting it by 273. Temperature in the degree Celsius is 27 degree Celsius. So we can simply say option number 4 is correct in this question. Let us come to question number 4. Here in this question, light travels a distance x in time t1. The speed of light is given by x by t1 according to the question. And it is traveling a distance of 10x in time t2. And that is a denser medium. The speed in that denser medium, let us write as distance traveled by the time taken. Time taken is t2. Refractive index is c by v, and the critical angle we can write it as sine inverse of 1 by mu. So if you put all the values here, you will get the critical angle to be sine inverse of tan t1 by t2. Third option is correct in this case. Let us come to question number 5. The angular acceleration of a body moving along the circumference of a circle. Angular acceleration, it acts along the axis of rotation. Third option. It is a cross product of two vectors, s vector and the tangential acceleration. Sorry, it acts along the axis of rotation. That's it. Question number 6. Ventimeter, we will know. It works on the principle of Bernoulli's principle. Simple theory based question. Question number 7. Half-life of a radioactive substance is 20 minutes. In how much time activity of substance drops to 1/16th of its initial value? Activity is directly proportional to the number of nuclei present. So number of nuclei is reduced to 1/16 times. So after first half-life period, number of nuclei present is n0 by 2. Next half-life it is n0 by 4. Next half-life it is n0 by 8. Next half-life it is n0 by 16. So we can count how many half-lives are there. 1, 2, 3 and 4. So 4 half-lives means 4 into 20 minutes. It is taking total time as 80 minutes. Third option is correct in this case. Now, question number 8. The errors in the measurement which arises due to unpredictable fluctuations in the temperature and the voltage supply are. These are the random errors that occurs randomly. Sudden fluctuation in temperature, voltage change, suddenly, sudden change in the moisture. All these errors are random errors. So option 3 is correct for question number 8. Question number 9. In question number 9, dipole is placed at an angle of 30 degree with an electric field intensity of 2 into 10 power 5 Newton per coulomb. It experiences a torque of 4 Newton meter. You have to calculate the charge on the electric dipole. If dipole length is given to us as 2 centimeter, you should convert this to meter. So torque, it is PE sin theta. Torque, it is 4 Newton meter. Dipole moment, we can write as Q into L. Electric field is given to us as 4 Newton meter into sine of 30 degree. Put the value of length as 2 by 100. Into 4 into sine 30 degree. On solving this, we get the value of Q as 2 millicoulomb. Third option is correct. Now, let us come to question number 10 now. Football player is moving southward suddenly and turns eastward with the same speed to avoid an opponent. The force that acts on the player while turning is. So it is moving southwards. What you can do? Make this as Cartesian system. This is I cap, this is j cap, this is minus j cap. So south is minus j cap. Initial velocity, let it be minus some constant into j cap, minus j cap. I'm writing. Some constant also you can write minus 𝐾𝐽. Same speed, it is turning towards east. So final velocity is K times I cap. So force is basically mass into acceleration. So direction of change in velocity will give you the direction of force. So change in velocity, we can find it out. Final velocity minus the initial velocity, it is K I cap minus K J cap. So it is K times I cap plus J cap. This is along northeast because I cap plus J cap is the direction of change in velocity, which will be the direction of force. So I cap plus J cap, if you mark it on vector Cartesian plane, it will be like this. So this is northeast direction. Second option is correct here. Let us come to question number 11. In question number 11, hydrogen spectrum. The shortest wavelength in the Balmer series is lambda. For hydrogen spectrum, Balmer series, we can write it as 1 by lambda is equal to R 1 by 2 square minus 1 by infinity square. This is for Balmer series. And for shortest wavelength in the bracket series, let the wavelength be lambda dash 1 by lambda dash is equal to R. N is 4 here, so 1 by 4 square minus 1 by infinity square. Just divide both the equations. 1 by lambda by 1 by lambda dash. This is R by 4 divided by R by 16. And finally, we get lambda dash is equal to 4 times lambda after calculation. So we get first option as answer. Let us come to question number 12. Magnitude and the direction of current in the following circuit is. You can see this is 10 volt, this is 5 volt. 10 volt is more dominating, current will go like this. Simply it will be from A to B only. So these options we can rule it off. Now potential difference here 10 minus 5 is 5, which is equal to I into R. R is 7 plus 1, 8 plus 2, 10. So current will be equal to 5 by 10, which is 0.5 ampere from A to B. It is passing by E. It is denoting its path, otherwise it could have written from it is passing via B to C. So it is passing directly A to B from via E through E. First option is correct. Question number 13. A 12 volt 60 watt lamp is connected to a secondary of a step down transformer, whose primary is connected to a AC main of 220 volt. Assuming transformer to be ideal. So if it is a ideal transformer, input power should be equal to output power simply. Efficiency is output power by input power and efficiency is 100%. Simply output power is 60 watt and input is also 60. So power is V into I. Power is given to us as 60. V input voltage is 220. And current in the primary winding, we can find it out is 60 by 220. After calculation, fourth option will be the answer. It is 0.27 MPu. Question number 14. Work function of cesium, potassium, sodium are given. If the incident electromagnetic radiation has an incident energy of 2.2 electron volt, which of these photosensitive surfaces may emit photoelectrons? Incident energy should be greater than the work function in order to emit the electron. So this 2.20 electron volt, it is less than 2.30, it is as well as less than 2.75, only it is greater than 2.14. So only cesium, Cs, the electrons will emit from the surface. Fourth option is correct. Question number 15. Potential energy of a long spring when stretched by 2 centimeter is U. So we'll use this formula. U is equal to half of kx square. X is simply we can write as 2 by 100. Final potential energy is half of k into 8 by 100 whole square. If you divide both the equations, you will get final potential energy as 16 times U. Third option is correct here. Question number 16. Magnetic field lines have a property that it always form the closed loop. So when it is a closed surface, once the magnetic field line entered, it has to go out. So net incoming flux should be equal to net outgoing flux. So net flux, it should come out to be 0. Fourth option is correct for question number 16. Question number 17. The amount of energy required for a saw bubble of radius 2 centimeter from a soap solution is nearly. Soap bubble has 2 layers. Basically, it is asking surface energy, amount of work energy required. So it is T into 2 into 4 pi r square. This formula we have to apply here. Put the values given in the question: 0.03 into 8 into 3.14 into 2 by 100 whole square. Just you have to go with the calculations here. After doing calculation, we'll get to know it is nearly 3.01 into 10 power minus 4 joules. Second option is correct here. Question number 18. A wire be suspended from a ceiling, rigid support and stretched by a weight W attached at its free end. The longitudinal stress at the point of cross-sectional area A of the wire is weight W is there, now tension at each and every point is W. And stress you have to calculate, it is restoring force divided by the area. So restoring force here is W and area of cross section already mentioned in the question, it is capital A. So we'll go with the first option here as answer. Question number 19. Little calculative. A body of two bodies of mass m and 9m are placed at a distance r. The gravitational potential energy on the line joining both the bodies where the gravitational field equals to 0 will be. You have to find, first of all, you have to locate the point where the field is 0. One is mass m, one is mass 9m. Both are at a distance of r. I'll consider a point. Let us say this distance be x and this distance be r minus s. Gravitational field intensity due to both should be equal and it will be in the opposite direction. So simply I am equating gm by x square is equal to g of 9m by r minus x whole square. From this, we'll get the value of x, and x will come out to be r by 4 after solving this. Now we can find potential. This distance is r by 4 and this distance is 3r by 4. Not visible, I think, no? Here it is 3r by 4. Mark this point as A. We can write potential at point A. It is minus gm by x minus g of 9m by r minus x. Put the value of x here as r by 4. So finally we will get minus 16 gm by capital R as the answer. Second option is correct here. Let us come to question number 20 now. To what temperature gas be heated so that RMS speed is increased by 3 times? Here term by is used. It is increased to 4 times. So if it is increased to 4 times, temperature, first of all, we have to convert to Kelvin. Minus 50 plus 273. It will come out to be 223 Kelvin. RMS speed is directly proportional to under root of temperature. So when it is becoming 4 times, temperature has to become 16 times. Because under root of T, under root of 16 is 4. So temperature is becoming 16 times 16 into 223. It will come out to be 3568 Kelvin. We can, because as we can see the options, it is in Kelvin or degree Celsius. Degree Celsius, Kelvin it is not matching. 3568 minus 273 we have to do. It will convert to Kelvin 3295 degrees Celsius. So it is 3295 degrees Celsius is the answer. Photovoltaic device can convert optical radiation into the electricity, that is true. Solar cell is the example. Xenon diode is designed to operate under reverse bias in breakdown region, that is also correct. So both the options are correct here. I'll go with the fourth option here. Question number 21. Question number 22. Closed integral of E dot ds is 0. It is given in the question over a closed surface. Over a surface. Closed surface, closed integral means closed surface only. Then which of the following option is correct? The magnitude of electric field on the surface is constant. It is wrong. We cannot say about electric field, it can be variable also. All charges must lie inside the surface. No. The electric field inside the surface is necessarily uniform. We can't say like that. It is the electric flux. Electric flux is 0. This means that net incoming flux is equal to net outgoing flux. So number of flux lines entering the surface must be equal to the number of flux lines leaving out the surface. Fourth option is correct. Let me move to the next question now. Question number 23. Here in 23, as you go with the options, some options kilohertz and some options are there with radians per second. So when it is radians per second, find omega. If it is kilohertz, then find frequency. So frequency at which resonance occurs, omega, we have a formula, it is 1 by under root of LC. L is given to us. L is 10 millihenry. So 1 by under root of 10 into 10 power minus 3 into C is 1 microfarad. It is 1 into 10 power minus 6. This is 1 by 10 power minus 9 into 10 is 10 power minus 8. It is 10 power minus 4 radians per second. So it is not any of the options. So put it equal to 2 pi f. F is equal to 1 by 2 pi into 10 power minus 4, so which is 10 power 4 by 2 into 3.14. So it will come out to be 1.59 kilohertz. As answer. First option is correct for question number. Sorry, third option is correct for question number 23. Question number 24. AC source is connected to capacitor due to decrease in frequency. Displacement current decreases. 24th, second option is correct because displacement current is directly proportional to the operating frequency. Second option is correct here. Question number 25. You can see here G is 9.8 meter per second square. So you have to take G as 9.5 meter per second square. You have to find the maximum height. The bullet is fired with a speed of 280 meter per second at an angle of 30 degree above the horizontal. We can use the formula of maximum height. It is U square sin square theta divided by 2G. After putting all the values, it's a formula based question. You will get 1000 meter as the answer. Okay. Now Question number 26 I am going to solve. Vehicle travels half the distance with speed theta. Remaining distance with speed 2 theta. Find its average speed. So we can use the direct formula here. Twice of V1 V2 by V1 plus V2. This is the formula of average speed if an object is traveling for first half of the distance with speed V1 and next half of the distance of the journey with speed V2. So it is 2 into theta into 2 theta divided by 2 theta plus theta, or you can write as theta plus 2 theta, one and the same thing. So for this question number 26, second option is correct. Question number 27. You have to find the color of the third band, and the resistance of the carbon resistor is given like this. We can write it like 22 into 10 power 3 plus minus 5%. So multiply, it should lie in the fourth row. B, B, R, O, Y. First row is black, next is brown, third one is red, fourth one is orange. When it is the case of the multiplier 0, 1, 2, 3 in the color coding. So third color is orange, which is 10 power 3 here reflecting. So it is second option as the answer. Question number 28. We can see this 3 ohm and 3 microfarad and 3 microfarad both are in parallel combination. You have to find the equivalent capacitance here. It will sum up to 6 microfarad. The 6 microfarad and 3 microfarad both are in series combination. So C equivalent we can write, I'll change the color. C equivalent, you can write it as directly 6 into 3 by 6 plus 3, which is 18 by 9, which is 2 microfarad. We'll go with the fourth option as the answer. Question number 29. Minimum wavelength of X-ray produced by a electron accelerated through a potential difference of V volt is proportional to. We have a formula, minimum wavelength. This is Hc by E maximum. Which is charge into the potential difference. So lambda is directly proportional to 1 by V. We'll go with the first option here. Question number 29. Question number 30. The magnetic energy is stored in the inductor of inductance 4 microhenry and current of 2 ampere. Potential energy, we have a formula, it is half of Li square. This is 1 by 2 into 4 into 10 power minus 6 into 4. This is 8 microjoules. Third option, we'll go with the third option, 10 power minus 6 is a microjoules here. screen, for a young double slit experiment, two statements are given. If the screen is moved away from the planes of the slit, angular separation of the fringes. Angular separation, we have a formula. It is fringe width by angular position or angular width. It is fringe width by capital D. So it is basically lambda capital D by small d into capital D. It is independent of the distance, angular position, angular width. So this option is correct. If monochromatic light is replaced by monochromatic light of larger wavelength, if you are going to increase the lambda, angular fringe width is going to increase here. So separation between the fringes will decrease is wrong. So first option is correct. Second option is incorrect. Question number 31 will go with the second option here. Here comes question number 32. The radius of gyration of a solid sphere of mass capital M, radius capital R, about its own axis to the radius of gyration of thin hollow sphere of same mass and same radius about its axis is. Moment of inertia is written as mk square, where k is the radius of gyration. So simply we can write k1 by k2 is under root of I1 by I2. Solid sphere, it is 2 by 5 mr square. Moment of inertia for a hollow sphere, it is 2 by 3 mr square. So it will be k1 by k2 is under root of 3 by 5. So now option is there. So I'll go with the bonus marks here. No option is matching. Question number 33. In a plane electromagnetic wave traveling in free space, the electric field components oscillates sinusoidally at a frequency of 2 into 10 power 10 Hz and amplitude 48 volt per meter. The amplitude of the oscillating magnetic field is, we have a relation C is equal to E naught by B naught. E naught is the amplitude of the electric field and B naught we need to calculate, it is the amplitude of the oscillating magnetic field. B naught we can write as E naught by C. E naught is given as E naught is given to us as 48. The speed of light is 3 into 10 power 8. There is no use of this value. It is there to confuse you. The value of B naught will come out to be 1.6 into 10 power minus 7 Tesla. I'll go with the second option. Metal wire. Question number 34. Metal wire has mass 0.4 plus minus 0.02 gram. Radius is also given. Length is also given. You have to find maximum possible percentage error in the measurement of density. First of all, we should write the formula of density. Density is mass by volume. Volume is pi r square h. So delta rho by rho. The power of mass is 1. We can write delta rho by rho as delta m by m. The power of radius is 2. So if you take it to up minus 2, but you have to write plus only, plus twice of delta r by r. plus delta L by L. Delta M by M is 0.02 by 0.4. 2 times 0.001 by 0.3 plus 0.02 by 5. Just multiply this thing by 100%. You will get the answer, and answer is nearly equal to 1.6%. I'm moving to question number 35. Question number 35, ratio of frequencies of fundamental harmonic produced by open pipe to that of closed pipe of the same length. Frequency produced in the open pipe, fundamental frequency, it is given by V by 2L, and for a closed pipe it is given by V by 4L. We'll just take the ratio F1 by F2, 1 by 2 by 1 by 4, which will come out to be 2 by 1. 2:1 is the answer here. Question number 36. Two thin lenses of same focal length f, but one is convex, one is concave, and they are placed in contact with each other. The equivalent focal length of the combination. Equivalent focal length, let it be f dash. Convex lens, if it is in near or medium, if it is positive, concave has to be negative. Focal length. So 1 by f minus 1 by f. So it is 0. From this we get f dash equal to 1 by 0, which is infinity. Third option. Question number 37. Satellite is orbiting just above the surface of Earth with time period capital D. Density of Earth is D and G is a gravitational constant. You have to find, you have to tell 3 pi by GD, what does it represent? Let us write the expression of time period here. Time period is 2 pi r by the orbital speed v0. So it is 2 pi r by under root of gm by r. So time period you can write as 2 pi r power 3 by 2 by under root of gm. Some people know this formula directly. I'll write this formula again because I think logo is coming there in between. So time period is 2 pi r power 3 by 2 by under root of gm. Now, if you put the value of mass as density into volume, if you just put this value here, we get T square, T to be equal to under root of 3 pi by GD. If you square this term, we get 3 pi by capital G into D is T square. First option is correct. Question number 38. In the figure shown here, the equivalent focal length of the combination of lenses. You have to find out. Assume all layers are thin. It is assuming to be thick, but you have to assume thin. So we can break it into 3 lenses. and we can see this lens, and this lens. Let us say this is having focal length f1, this is having f2, this is having f3. So we can write f1 is equal to f3. Both are same. So we can write 1 by f1 as 1.6 minus 1, 1 by infinity minus 1 by 20. I am putting the values in centimeter. Finally, after the formula of combination of lenses, we will get the answer in centimeter only. And this is 1 by f3 also, the same thing. 1 by f2 you can write as 1.5 minus 1, 1 by 20 minus 1 by minus 20. First radius is positive, second is negative. Finally, we can write as 1 by f as 1 by f1 plus 1 by f2 plus 1 by f3. From this, putting all the values, we get focal length to be equal to minus 100 centimeter. I'll go with the second option here. Next slide. Question number 39. A bullet from a gun is fired on a rectangular wooden block with a speed u. When bullet travels 24 centimeter through the block along its length horizontally, the velocity of the bullet become u by 3. It further penetrates into the block in the same direction before coming to the rest exactly at the other end of the block. Total length, because it is coming at the rest at the other end of the block. So whatever the distance traveled by the bullet here is equal to the length of the block. We will go with the third equation of motion here. V square minus u square is equal to 2as. Finally, its speed is becoming u by 3. So I write it like u by 3 whole square minus u square. This is equal to 2 into a into 24 centimeter. I'm assuming it into centimeter. I'm not converting units. Let us take CGS unit system. It's better. It will save our time from the calculation. Finally, it is coming to rest. From the initial velocity, let us say total distance traveled by it is s. Just divide both the equations, equation 1 and equation 2. So by dividing equation 1 and equation 2, you will get the value of s. We will get s to be equal to 27 centimeter, and s is the total distance traveled by it, which will be equal to the total length of the block. Fourth option we can mark as answer. Question number 40. There are 10 resistors. Each of resistance are connected in series to a battery of EMFE having negligible internal resistance. When these are connected in the parallel to the same battery, current increases n times. You have to find the value of n. So when 10 resistances are connected in series, net resistance is becoming 10R. EMF is E. Current is I. I we will write it as E by 10R. When they are connected in parallel, that is R by 10. EMF is E. Current is I. I dash we can write it as I dash is equal to E by R by 10. Divide both the equations. I dash by I, it will be equal to 100. If you divide both the equations, second equation by the first equation, and n is the ratio of their current, it is 100. Question number 41. Question number 41. You have to find the net impedance of the circuit. In order to find the net impedance of the circuit, we have a formula Z is equal to under root of R square plus omega L minus 1 by omega C ka whole square. Simply you have to put the values. Under root of 10 square, omega is 2 pi f. So plus 2 pi, f is 50 and L is 50 by pi. Just wait, I don't have space here. I'll write it here. Under root of 10 square plus omega is 2 pi f. So 2 pi into 50. L is 50 by pi millihenry. So we can write as 50 by pi into 10 power minus 3 minus 1 by 2 pi into 50 into 10 power 3 by pi into 10 power minus 6 whole square. If you solve it, you will get it as under root of 125, because this the second term, if you solve it, it will, if you solve it, this term, you will get it as 5. 5 square is 25 plus 100 is 125. So answer is 5 root 5. We'll go with second option as answer here. Question number 42. Here the position time graph is given to you. You have to find the acceleration at time t equal to 2 seconds. So it is a simple harmonic motion because position is varying sinusoidally as a function of sine. At 2 seconds, its position is 1, amplitude is 1. Acceleration for a simple harmonic motion, we have a formula, it is minus omega square x is 1 there. So omega is 2 pi by t, time period is 8 seconds. So it is 2 pi by 8 whole square into 1, which is minus pi square by 16 in SI unit system. So I'll go with the third option here. Question number 42. Now here comes question number 43. Question number 43, a very long conducting wire is bent in the form of semicircular shape A to B as shown in the figure. The magnetic field at point P for a steady current is given by. If current is going in this direction, magnetic field at point P is inside the plane. By right hand thumb rule you can easily analyze, and due to this also it is inside the plane. If you sit at point P, this current is anti-clockwise. For anti-clockwise current, magnetic field is out of the plane. So I'll break it into 3 parts, wire 1, wire 2, wire 3, and I am taking out of the plane current to be positive. Magnetic field to be positive, sorry. So magnetic field due to wire 1, it is mu naught I by 4 pi r inside the plane. Magnetic field due to wire 2, it is mu naught I by 4r. Here r is capital, so we'll put it as capital R only, by 4r out of the plane. And magnetic field due to wire 3, it is mu naught I by 4 pi r inside the plane. So if you sum up vectorially, I'll go with second option as the answer here. we have to subtract this and this from this. Question number 44. Dipole is shown in the figure. Electric potential in 10 power 2 volt at point P. Already 10 power 2 they have taken. See, this distance will be 2 and this distance will be 5 plus 3 is 8. And this is in centimeter, remember. So potential at point P, due to charge Q, it is kq by 2 into 10 power minus 2. Because centimeter you have to convert into meter. And due to minus Q, it is k into minus Q by 8 into 10 power minus 2. So it is kq by 2 minus kq by 8 into 10 power 2. 10 power 2 we will remove because already it is 10 power 2 times v. So this thing we have to calculate. So taking LCM we will get it as 3 kq by 8. We will go with the fourth option here. Let me move to question number 45 now. Resistance of a platinum wire at 0 degree Celsius is 2 ohm and 6.8 ohm at 80 degrees Celsius. The temperature coefficient of the resistance of the wire is. For this question, you have to go with this formula. R is equal to R naught 1 plus alpha delta T. R you can assume it as 6.8. R naught you can assume it as 2. 1 plus alpha 80 minus 0. From this, we get the value of alpha as 3 into 10 power minus 2 per degree Celsius. So I'll go with the second option here in question number 45. Question number 46. A wire carrying current I along positive x-axis has length L. It is kept in a magnetic field. So wire you can assume either to be 2 I cap or minus 2 I cap. Direction is not mentioned and we have to find the magnitude of force. So to find the magnitude of force we can use this formula. F is I L cross B. So I L is L I cap cross 2 I cap plus 3j cap minus 4k cap. If you solve it, you will get I L 3k cap plus 4j cap. So this is in the vector form. Just try to calculate in the magnitude wise. It is I L under root of 3 square plus 4 square, which is 5 IL. So I'll go with the second option here as answer. Here comes question number 47. Calculate the maximum acceleration of a moving car so that the body lying on the floor remains stationary. Static coefficient of static frictional force between the body and the floor is given as 0.15. Here there's a moving car, suppose there's an object. So there is static friction acting between this body and this surface, and maximum static friction that can act, which is mu into n, 0.15 into mg. And this is only the static frictional force that is providing acceleration to the mass. So we can write mass into maximum possible acceleration. So maximum possible acceleration is 0.15 into 10. It is 1.5 meter per second square. Second option is correct. Question number 48. The radius of innermost orbit of hydrogen atom is given, and radius of third allowed orbit of hydrogen atom. So radius is directly proportional to n square. Simply multiply by 9. 9 into 5.3 into 10 power minus 11 meter converted into angstrom. It will come out to be 4.77 angstrom. I am multiplying it by 10 by 10. We get third option as correct. Question number 49. If you connect two NOT gate with a NAND gate like this, it will become OR gate. The truth table of OR gate should match here. Or you can go individually. If you put 0 and 0, supply 0 and 0. 0, 1 will come here, 1 will come here. Output of a NOT gate for a 0 is 1. 1 and 1. For a NAND gate, its output will be 0. Now, if you take 0 and 1, for 0, NOT gate output is 1. For 1, NOT gate output is 0. For 1 and 0, NAND gate, its output is 0. I said wrong, it is 1. Because 1 into 0 are, that will be 1. Similarly, for 1 and 0, it is a symmetric, its output will be 1. Now I'll write for 1 and 1. For 1, it is 0. For this one, it is 0. For 0 and 0, it is 1. So it is simply the truth table of OR gate. I'll go with the first option here. Question number 50, last question. Horizontal bridge is built across a river. Student standing on the bridge throws a small ball vertically upwards with a velocity of 4 meter per second. Ball strikes the water after 4 seconds. Height of the bridge. See here, ball will go like this and will come like this. Negative of the displacement is a height. So we'll find the displacement. Y is minus h, which is equal to ut plus half at square. U is 4, time is 4, g is 10 into 4. So it is 16 minus 80, which is minus 64 meter. So h will come out to be 64 meter here. And I will go with the second option. And we are done with the solution of physics. Thank you everyone.